Hello students. Now the so many non-parametric tests we have seen. Okay. The first one was the Mann-Whitney test, Mann-Whitney U test, and in this case we compared two independent samples. Okay. The next after that when the samples came in pairs, okay, for the interrelated or correlated, or we can say the paired samples, we used Wilcoxon's test, Wilcoxon's signed rank sum test. Okay, for that two samples in pairs. Okay, now, when there are more than two samples in pairs, okay, at that point of time we will be using our third kind of non-parametric test called as Friedman test. Okay, so from this we know that more than two samples are in pair. Like for example, in the Wilcoxon test, we saw an example where a rainfall was compared. Okay, for almost 10 years, it was compared at two places. Now, if suppose I have an example where it is compared at suppose three places A, B, and C for the 10 years. Okay. Now, in such cases, when it was only A and B, we used Wilcoxon's test. But if there are more than three cases, more than two cases, that is suppose A, B, and C. Now, in such cases, we will use this Friedman's test. Okay. Now, more than two means it can be four, five, seven, eight, anything. Okay. Now, again, our null hypothesis in this case will be what? Null hypothesis will be that all these samples are not significantly different. That is what? There is no significant difference between the samples. Okay, or this can be even written as that this all the samples come from the same population. Uh, so it is one and the same. All the samples comes from the same population. But most of the time this first one is used based on the question. Okay, now next one will be again writing the alternate hypothesis. It will be what? There is significant difference between the samples. That is what? All samples does not come from the same population. Okay, so there is significant difference between the samples. Now, after this, next step is setting up the level of significance 5% or 1%, and then using our test statistic. Test statistic in this case is represented by this Fm for Friedman, F for Fried and M for man, Friedman, that is called given by 2L divided by N into K plus 1 into summation R square minus 3nk plus 1. Okay, now I will explain what is this n and k. Okay, now this n is the number of observations, or the n is equals to sample size, I will say. Okay, and k is the number of types of samples. That is what? Now if we are comparing a rainfall at three places, that means my k will be 3, and if we are comparing it for 10 years, okay, then my n will be 10. Okay, this is the difference between n and k. You have to be careful with this. Looks quite similar. Okay, so now we'll see how this test is applied to an example. Okay, so now if I see this example, following data represents the number of units of tablets tablets production per day by 5 technicians using 3 different machines. Judge whether the 3 machines are same or not. Okay, now in this case again, A, B, C, D, E are the technicians and machines are X, Y, and Z. Now in this case, for a technician A is producing the tablets on machine X, he's producing on machine Y as well as on machine Z. That means what? These all data are in pairs. Okay, and there are more than 2 pairs. Therefore, we will be using Friedman test. Now it was only X and Y. If only X and Y data was given, we would have used the Wilcoxon pet sign rank test. Okay, but since there are more than 2, we will be using this Friedman test. Now, the next step for this is giving allotting the ranks. Now, how to allot the ranks? Now, in the previous example, what we have done is we had combined all the data and we had allotted the ranks. Okay, so now how to allot these ranks? Now, allotting the ranks is slightly different as we had done in the previous one. In Mann-Whitney test, what we had done is we had combined all the data. Even in the Wilcoxon test, we combined all the data and we allotted the ranks. But now in this case, we'll be allotting the ranks in pairs. Okay. Now let's see for this A. For technician A, that is the first sample or the first observations of each samples. Okay. So for out of this 54, 48, and 57. 54 of X, 48 of Y, and 57. Now which one is the smallest number of this? The smallest number is 48. Okay. Only of these numbers we are checking. Smallest number is 48. So I will allot this a rank 1. Okay, I'll just write it here rank. Then which is the next smallest, that is 54. So I will allot a rank 2 to this. And after that the highest one is the 57. So I will allot the rank 3 to it. Okay. So this was allotted the ranks in pairs. Now let's move to the technician B. Now the observations of technician B are 56, 50, and 62. Now out of this again the smallest is 50. Therefore I will allot a rank 1 to it. Next is 56. So I will allot a rank 2. Next is 62. So 3. Let's move to the technician C. Now, out of these, the ranks are 44, 40, sorry, the observations are 44, 46, and 54. The smallest one is 44, so I will allot a rank 1 to it. Now, next is 46, so 2. 54, therefore 3. The next is what? 48, therefore 1. 53 will have 2, and 56 will have 3. Next is, in this case, 41 is 48 is the smallest. Okay, so it will have 1. 52 will have 2 and 59 will have rank 3. So if we see all the samples or all the datas have been allotted the ranks. Now I will just add those ranks, that is summation r. Rx it will be. Okay, then here summation ry, and in this case it will be summation rz. So if we see, it will be 2 plus 2, 4, 5, 6, 7, 8. So this summation r is 8. That is r1. Then this one will have 1 plus 1, 2, 4, 5, 6, 7. This one will have 15. Okay. So this is my r2. This is my r3. Now the square of this, we will require the square of these numbers. R1 square will be 64. R2 square will be 49. and R3 square will be 225. Okay. Now, once these data have been calculated, next step is setting up of our null hypothesis H naught. Now, what is the H naught? Now, the question is about judging whether the three machines are same or not, or is there any significant difference between the three machines. So, my null hypothesis will be in the similar manner that my null hypothesis will be there is no significant difference between the three machines, or the three machines are similar, but the better way is there is no significant difference between the three machines. Okay. Now, similarly, what will be my H1? It will be the opposite to it. That is what there is, or the three machines, better word is this, the three machines are significantly different. Now, once H0 and H1 has been set, let's choose the level of significance. Suppose say 5%. Now it is nowhere mentioned in the question, but let me guess it for 5%. I will even check it for 1%. That is fine. But let me set to 5%. Now, once this data has been given, next step is setting up the test statistic. Now, in this case, the test statistic is my Fm equal to 12 upon n into k plus 1 into r1 square plus r2 square plus r3 square now. Okay. Minus 3n into k plus 1. Now, what are my n and what are my k's? Now, I had said the number of observations. The number of observations is n. So, A, B, C, D, E. These are my objects. Okay. So, this number of observations will be n. That is 5. Okay. And how many things are compared? That is X, Y, and Z are compared. It is three kinds of samples are compared. Okay. Therefore, my K is equals to 3. So I have here n is equals to 5 and k is equals to 3. Even have this r1 square, r2 square and r3 square. So I will just substitute. And again, don't get confused how this 12 has come. This 12 has come from the no, from the formula. It is a part of the formula. Okay. And yes, I forgot to mention here the degree of freedom in this case is k minus 1. Okay. So in this case, my degree of freedom will be k minus 1, that is 3 minus 1, that is 2. Okay. Okay. So now I will calculate this. I will just substitute for my fm. N is equals to my 5. K is equals to 3, and this is 3 plus 1, therefore 4 into r1 square. Now what is r1 square? We have seen r1 square is 64, r2 square is 49, and r3 square is 225. Okay, so 64 plus 49 plus 225 minus 3 times this n is my 5 again, and k plus 1 is 4. Okay, so when you solve this will be 12 will be cancelled with these 3 comma 4. Okay, and whenever you will solve this further, you will get this around 7.6. This will be my fm value. This will be my calculated test statistic. Now I need an critical value whenever there is some hypothesis stuff. Okay, that means there comes into picture a critical value, and we compare the calculated value with the um, tabulated value or that critical value. And if the calculated value crosses the critical value, that means it is the null hypothesis is rejected, and if not, it is accepted. So this is the common step. Okay, now in this case, how to calculate the critical value? Now degree of freedom we have calculated, that is k minus 1, that is the degree of freedom comes out to be 2. So what we will do is, now if my level of significance was set at 5%, now 5% means alpha is equals to 0.05. I will use my chi-square table. Now how to look into this chi-square table? Now either the chi-square table will be provided in for you in the exam, or the chi-square value will be given. Now let's see. My degree of freedom was 2, so I will look here for the degree of freedom, these 2. Okay, and since it was 0.05, I will look at here for this 0.05, that is 5.991. Okay, so now this 5.991 is my tabulated value, is 5.991. Now obviously my FM, the calculated value 7.6, is greater than this 5.991. That means what? 7.6 is greater than 5.991. That means what? My null hypothesis H naught is rejected. Okay? That means what? There is a significant difference between these three machines. Okay? That is my conclusion. There is a significant difference between the machines. Okay, so this is how you proceed with this examples. Now I just give a quick revision. Now in this case of Friedman's test, this is again a non-parametric test. Now this is a continuation of Wilcoxon test. See, the first basic step is Mann-Whitney. First basic test is Mann-Whitney U test. Okay, in which independent samples are tested. Then next is Wilcoxon signed rank sum test. In this, two pairs of samples are tested, and when there are more than two pairs of samples to be tested with each other, we use Friedman's test. Okay, now in this case, the first step is allotting the ranks each. Okay, pairwise ranks we need to allot them. Okay, so allotting the procedure of allotting the ranks is quite different as compared to the Mann Whitney and Wilcoxon. So this thing you will have to keep in mind. Now, once the ranks has been allotted, next step is setting up the null hypothesis that there is no significant difference between the samples. Then setting up the alternate hypothesis that there is a significant difference. Then setting up the level of significance, and then the test statistic. The test statistic is given by this formula. This formula you will have to keep in mind, the 12 upon nk into k plus 1 into r1 square plus r2 square plus r3 square and so on. That depends on how many samples are there which you need to compare. Okay, minus 3n into k plus 1, where n is the number of observations taken and k is the number of samples to be tested. Now, once the FM value has been calculated, we will calculate the degree of freedom that is given by the k minus 1. And with that degree of freedom, at the particular level of significance, we can test the either that tabulated critical value will be we can take from the table, or it will be given to us. Okay. So this once that tabulated value or the critical value we have got, we can compare it with the calculated value, and based on that we will conclude about our acceptance or rejection of our hypothesis. Now, just in mind, in the exam it can be directly given that chi-square value of so and so is this. Now for this, the chi-square value, which is 5.991, it is at 0.05 level of significance and at degree of freedom 2. So this chi-square is even represented as 0.05 comma 2. This means that it is at 5% level of significance at degree df is equals to 2. Okay, so it is chi-square is equals to 0, 5.991. This is how it is represented. So in this way also the chi-square value can be given. That means what? You will have to understand that this chi-square is, or this significance or this hypothesis is tested at 5% level of significance. Okay.